Hello everyone and welcome to Packaging Europe's live week. You may notice the background behind me giving a clue to the context for this series of broadcasts that we're producing. Today should have been day one of Interpack, and we had big plans, lots of things to discuss, and in particular a focus on sustainability. And therefore it's apt that we commence with a key sustainable packaging initiative, namely CEFLEX. We're going to be presenting a webinar today with the subject of boosting value and keeping materials in the loop, delivering a quality recycling process. Over the last few years, I've been closely watching the CEFLEX project and been incredibly impressed by the progress and the professionalism that it's displayed. It's one of the most important sustainable packaging initiatives at the moment, with a practical and coordinated approach to realizing a viable circular economy in flexible packaging through value chain collaborations, focusing on technology specifications and the all-important economics of a circular economy. CEFLEX is also a key collaborator in the Sustainable Packaging Summit, which we have planned for October this year in Lisbon, and we're looking forward to working with them over the coming months. I'm going to hand over in a moment to Alec Walker-Love, who's going to be leading this webinar. But also wanted to point out that we'll have a time to answer some of your questions at the end of this. So please feel free to submit any questions through the YouTube chat function where you're watching at the moment. Great. I'm going to hand over now. Alec, it's all yours.
Good morning. Thank you very much, Tim, and I hope you can hear me okay. We are very pleased to be participating in this virtual Interpack event, and particularly like your virtual background, Tim. And it's really sort of put us in the mood for having some of those essential discussions. And I think one of those essential discussions is about how do we build the circular economy for flexible packaging. And we really are facing a bit of a race against time for the planet, for consumer preferences, and for regulation. And a key part of that is the end markets for recycled flexible packaging materials. And so we're delighted to have a whole work stream dedicated to this, led by Dana Mosora, and have a panel of experts with us today exploring these issues. So with no further ado, I'm going to ask Dana to give us an introduction really about what quality recycling process is about and why it's important for achieving our roadmap and collective vision for circular economy for flexible packaging.
Well, Alec, while I wait to be seen by the audience, let me start by saying that it's clear that the current way of treating flexible packaging after disposal by consumer, it's today not enough from many perspectives, which is why we're working so hard towards driving a circular economy for flexible packaging. As CEFLEX to help realize for the value chain an ambition vision in which both higher recycling targets and a circular economy are realized in parallel, CEFLEX sustainable end market stakeholders are working together to demonstrate a quality recycling process, which is able to deliver polymers for non-food applications like collation shrink, pouches, bags, or labels. This quality recycling process is the name of the new game, where performance infrastructure and processes are able to boost recycling rates, create value, and keep resources in the economy at the highest value possible. This is all about creating value via more advanced processes, which make possible putting on the market new recycled polymers for value-added new end applications. This is enabled by design for recycling of flexible packaging in a circular economy, which further enables design from recycling of new value-added products. We're looking at several aspects in parallel: the design of a new quality recycling process, the characterization of these recycled materials produced, and the development of the various end applications targeted. What we see happening across Europe these days is a focus on recycling as much of the flexible packaging as possible, everywhere, from Italy to Belgium and Netherlands, and now to France and even UK. New sorting plants in Germany, Belgium, Nordic countries are today designed to sort for recycling a much higher part of the flexible packaging collected than what was before, and are targeting not only the large films or polyethylene packaging, but all the polyolefin flexible packaging. This new design of sorting plants by itself delivers an increase of how much plastic is sorted for mechanical recycling in Germany, for instance, from 15% historically to 35% now, and reverses the rate of plastic packaging sent to energy from waste processes from 35 to 15% now. So you can see the difference. It comes from both the sorting by polymers, regardless the size of the packaging, and by choosing to sort for recycling both polyethylene and polypropylene type films, or any combination of these. So we can now see living sorting plants in Germany, new polyethylene film base and polyolefin flexible packaging waste bales, which are shortly called POFLEX. And this brings me to explaining this quality recycling process. What the CEFLEX quality recycling process brings new is a continuation of the recycling process of flexible packaging from where the sorting plants deliver the commercial bales, which are sent to recyclers for valorization. So this quality recycling can start from, for instance, the well-established recycled polyethylene film bale, which undergo further sorting out of all the recycled PE film, not colored and not printed. This fraction is then submitted to hot washing and extrusion with extrafiltration, followed by a deodorization step, which result in higher quality polyethylene film grade than the infeed material to the process. In parallel, all the rest of the incoming bale, the drop of the recycled PE film, follows the same advanced recycling process to elevate its recycling value for the highest possible end application. The big news which we have to share at CEFLEX today is that the polypropylene can also be recycled from flexible packaging. If we apply this quality recycling process, starting from the new sorting specification to the so-called POFLEX, then we would get recycled polypropylene film O grade. But you will hear more about this later. So right now, we are validating these new recycling technology processes, which we tested at experimental scale last year, and we're moving into industrial scale this year. This by itself will enable the production of enough large volumes of new quality of recycled polypropylene and polyethylene of film grade to explore new end market applications. And based on the results from all this work, and you will hear from the next speakers more about, we will then start to build the business case for investment into the quality recycling process at sorters and recyclers, moving full speed into the various new end markets. This is what I had to say, Alec.
I just want to ask if we can go to our first couple of experts. We have Michael Langan of HTP and Barry Ballard of Etero. And I'd just like to ask them to speak for a moment about why this hasn't been happening and some of the barriers to achieving a quality recycling process. So I'm going to hand over to Michael Langan first.
Hello to everybody out there. Now, Tim, the question about why don't we see more mono PP or mono PP structures in the packaging market is maybe because a lot of the packaging producers and material producers do not even know about the recyclability of their own packaging. So firstly, to improve and to make packaging more recyclable, you need to know about the recyclability of your own packaging. So with us at HTV, together with other experts, we teamed up and we set up an assessment procedure to measure the recyclability of packaging and to issue a certificate where it is clearly stated to which extent a single packaging is being recycled. So this can be done by a scientifically proved process and a process and a methodology which is widely accepted in the industry. It is orientated on the actual collection and sorting and recycling infrastructure. So it is quite realistic in its reflection of the present structures and to which extent the packaging is recyclable. So that is the side of the measurement, but how can we improve? So to improve and to make more volumes and more packaging recyclable, we need to have capacities. As we do see a lot of new sorting centers being built right now in Germany, in Belgium, in the Netherlands, even in France and Italy, we do have a lack in recycling capacities. And that is particularly true for the flexible packaging market. So all of the bales coming out of the sorting centers, they need to be recycled by the old technology Dana currently presented. And we do have a lack of it. We do need more of these recycling centers. We at HTP, the engineers of HTP, we do design those recycling facilities. And we know that at least about 10 to 15, maybe even 20 of those large recycling centers are needed across Europe to make more flexible packaging recyclable, because we do need as well capacities as well as end market applications. Okay, just 2 or 3 more sentences, Barry, before I hand over to you. So I don't want to go into any technical details. So this is just a bird's eye view onto one of these sorting centers. It's quite sophisticated. You do see the logistical units. You do see the halls and the silos to store the granulates and the compounds. And what I would like to emphasize additionally is the investment needed. So we do know from various projects that around, so that is a very rough figure, that we do need about 1 million euros of investment per 1,000 tons capacity annually. And this is for all the units needed up to the end of a regranulation in the compound. So how do we finance that such kind of a sorting center? It's financed by the so-called EPR system, extended producer responsibilities, where the packaging producer and the material producers pay a certain fee to a national EPR scheme, and from these financing structure, these investment and the operation of those sorting centers can be financed. Now, I would like to end my statement. I don't want to cover too much time, Barry.
Great. Thank you very much, Michael. It's a considerable investment, and obviously one, and that's an interesting figure that you have there, 1 million per 1,000 tons a year. I'd like to ask Barry, you see another side to this working in the recycling plant. What do you see as the main barriers?
Yeah, thank you, Alex. Good morning, everybody. As stated, I'm working for Attero, and Attero is one of the companies, I think one of the biggest sorters and recyclers in the Netherlands. And the example that Michael Langan just showed, is the kind of operations we run at the moment. So the issue, why is quality recycling not going on at the moment, or at least not as we like to have it? It's all about quality, it's all about money. To make more recycled flexible PE and PP packaging possible, we have to focus on first collection and sorting and recycling of film, and striving to produce the quality of all recycled materials to the highest level as possible. This means using top quality when top quality is needed, but also accepting that for some applications, when we talk about cover hoods, about shrink wrap, film wrap, impeccable optics is not a necessity, but it's an example of a habit born in the past. Adopting a mindset of design for recycled content or design follows function can mean tuning the quality of materials to the purpose of the application. So we have to educate everybody, every citizen, every business partner, that imperfection in film packaging like dots, spots, color differences is not a matter of failure, but a sign of optimal use of resources. For much too long, we have been focusing on cost instead on quality. There are many techniques in use, and we will show them, and the other presenters will show them later on, but not a lot of them are reaching their full potential at the moment. For example, if a sorter or a recycler focuses on throughput instead of quality, yes, the cost for this activity will be lower, but this also means that the quality will be lower. And as long as a recycled polymer has to be cheaper than virgin, and we have to ask ourselves the question, why is this necessary? The whole chain will focus on cost instead of quality. I think if producers, brand owners, retailers and more would be willing to pay at least the same price as virgin, a much more better quality is possible, also for PE and PP film. The example can be seen in rPET. But we also have to accept that recycling rates, at the moment more seen as collection rates, might drop when we change our focus from quantity to quality. Thank you.
Great. Thank you, Barry. That's an interesting take also about consumers and their imperfections. And we might need to understand and value that that is also part of saving the planet and keeping these resources inside a circular economy. Those small imperfections might be a trade-off that we should get our heads around. So thank you for that introduction, both. I'm going to ask now that we sort of look at the practicalities of how we make that shift, and I'm going to ask Oliver Lamberts of TOMRA Sorting to come in and say a few words, and be joined also by Daniel Zieler of HERBOLD and Clemens Kitzberger of EREMA as well in this segment. So I'm just going to see whether we can't share the screen a little bit more effectively this time around and put that up on the screen.
Okay. Good morning, everyone. Yes, first of all, I think to your question, Barry and Michael already made some right statement. I think it's really important that we need end markets and end applications for different qualities of recycled fractions. In that sense, I'm very positive that we see already what we call a pull factor coming from the packaging industry and from brand owners. So there is a clear demand for high quantity and high quality material for the future. And I also believe and hope that like the commitments and pledges that are made by the industry are no empty promises. So then the responsibility for our industry, that means the waste and recycling industry, is then of course to develop concept solutions that will be able to deliver the qualities and quantities required then by the industry. So this work, from my point of view, needs to be done in a collaborative way. So in cross-value chain project, by joining forces, by joining expertise, and I think that the work that we do here at CEFLEX is a pretty good example of such a cross-value chain collaboration. So finally, from a Xorter's perspective, of course, we have the ambition to recover more flexible packaging in the future from different types of waste streams than today. What we see today in many markets is that there is less focus on flexible packaging than on the rigid, for example. So yeah, in addition, we will clearly need a stronger focus on quality in order to be able to replace more virgin plastic. So the technology, and that's, I think, the good news, the technology to achieve this is, from our point of view today, available in the industry, in the market. And we just need to combine it in a smart and in an economical, feasible way. So what we did at CEFLEX was actually to apply our standard near-infrared and color sorting technology. We used a small sorting line nearby our headquarters here in Koblenz. And yeah, you can see here on the images what we did. Dana mentioned that initially already we got two different types of input material. On the left side, you see the 310 LDPE fraction. Here we separated natural PE film. And then on the right-hand side, you see the POFlex material where we separated mixed colored PP. In both cases, we applied what we call a two-step sorting. That means an additional cleaning step, as we did not use any manual quality control here. So yeah, then finally we were left with 4 different output fractions. All of them were baled and then sent to our next partners to hot washing. And that's, I think, when I can hand over to Daniel. Thank you.
Thank you. Daniel, you want to talk us through the hot washing process?
Well, for sure. I mean, Dana explained in the beginning already what is the whole sequence of processing the plastic waste into a product which finally can be perfectly reused. Well, we at HERBOLD, we have a huge test center. We are also participating in this whole development. And we have taken the share of washing, the output from the pre-sorting. We have a full-size wash line. The traditional washing is always wet plastics, and it has been cold all the time. Well, we have started a few years ago already to introduce the hot washing in order to make the next level. A next level means through wet washing, you take out minerals, other plastics through density separation, also paper. You reduce the organics, but you are not tackling the glue. You are not also tackling the smell as perfect. So we have done the whole process here in-house in our technical center and processed a number of tons. And if you can go to the next slide, Alec. Here we see the input and output. On the left-hand side, it's the pre-sorted natural film. It's mainly natural. You see here and there also some green film. You also see that there is still waste inside. So what we need to do is take all that waste out and process this into a light, nice, shiny flake. And that's what you can see in the center picture, from gray to really light, nice, white flake, which can go into the next stage of extrusion. On the right-hand side, there's a number of waste products which we are taking out. And in total, we achieved here with that film about 85% of film recovery. So about 15% was left as a waste. And on the next slide, Alec, there's the other stream, the drop fraction. So anything which was left after pre-sorting and taking out the natural film. Here you can see again on the left-hand picture it's still a waste. It's a mix, it's a concentrate, yes, but it includes a lot of impurities. And here we did the same. We are taking out the impurities through the washing in order to prepare it for the next stage of extrusion.
Perfect.
Yes.
Thank you very much, Daniel. I think, Dana, you're going to say a quick word also about this decontamination.
Yes, I can talk about hot washing trials on the POFlex waste stream. In this case, this trial was not performed by a CEFLEX stakeholder, but by an external one, the Italian technology provider EREMA, using their pilot unit in Previero. Hot washing was done also at 85 degrees Celsius with 1% caustic soda, 0.3% detergent. As this is indeed a new waste stream, is most likely polyethylene and polypropylene either co-extruded or laminated together. The hot washing trials for both fractions deliver a very good decontamination, as you can see in the photos.
Indeed, there's some great images there. And thank you, Donna, for talking about those trials. So the sorting and washing, we have Clemens here from EREMA who can also speak to us about the extrusion process. So Clemens, you tell us about the trials happening.
Thank you, Alec. Good morning, everybody here from Austria. Yes, I'm really proud to be a member of CEFLEX with the EREMA Group and to be in this team, because high quality recycling means that all the steps have to be on a high level, like sorting, washing, and extrusion, that every step can perform at this best level. So in this CEFLEX test series we used extrusion system called TV Plus, which is already on the market since a few years. But the new prepared material give us some very new perspective or new possibilities in extrusion. That means as the surface of the flexible film flake is very nice cleaned, what you can see over here, I did a comparison on the green line. What is a typical retailer LLDPE pellet quality? That means a collection from retailers. But of course, the film is natural and very low contaminated compared to a household waste film. Here we did a lab test on a lab cast film line and count the spots. And you can see the next blue line, the PE natural, which was sorted out of this household waste and hot washed. We could get very near already to a retailer film quality in kind of spots and shales due to a 50 micron filtration, what is half less than it is standard nowadays in household waste film. That means there we can go into new products with this repellet. At the moment, not food grade applications, of course, so non-food applications, but it's around 20-25% of the stream, of the household waste stream. So it's a big amount of pellets which could go back in high application, what we can see later on from the converters. On the statistic or on the graph, you can see also the POFlex, which is the pink line, which is a mix of PP and PE, what is dedicated for injection mainly, but also over there we could go down to 125 micron filtration, what means it can be used in very thin walled products again. And the green line on the top, this was a RPP, a mixed RPP, so printed, colored, which was also extruded down to 32 micron, what was possible due to the preparation of the material. So also there, we made big steps forward to use such a recyclate from PP back in a BX film, for example, what we hear later again. All or some of the pellets we are running through another equipment called refresher to deodorize the pellets, where we have already food grade approval on HTP rigids. So there is also a way forward to enter these applications, but at the moment, of course, also for non-food flexible applications is important that there is no odor, not too much smell to go into high quality products. Thank you for the time. Thank you for listening. Bye-bye.
Great. So thank you very much to the participants in this part of the pilot and trials with TOMRA, HERBOLD and EREMA. We can see there the quality needed at every point along the way, and how essential that is in the sorting, washing and extrusion phases. So we're making all of this effort, and so I'd like to ask in our next section about, well, what does that deliver? Once we've done all of that effort, what are the possibilities that become available and opened up? So I'd like to invite our next speakers from PLASTOTECNICA RKW Group and Taghleef to give us a little overview here. And I'm going to speak first with Valentina Better from PLASTOTECNICA.
Thank you, Alec, and good morning, everybody. As Donna said at the very beginning, at the moment, no recycled polyethylene coming from household waste management could be properly used on demanding film application. Now we have the chance to change this situation. And here in PLASTOTECNICA, we tested the recycled polyethylene coming from this quality recycling process in a blown lab plant in order to understand if it was suitable for some other industrial film application. We produced 50 and 80 micron film with 30, 50 and 100% of recycled polyethylene inside. The extrusion process parameters were a little bit more unstable than usual, and the plant required more cleaning steps. Anyway, as you can see in the picture in the slide I prepared, we could obtain some good films. And from an optical point of view, you can see the film has a yellowish color, and and has a lower transparency. Haze, as you can see in the graph, is more or less 40% worse compared to virgin material. While the surface gloss is not so much affected by the presence of recycled polyethylene inside. From a mechanical point of view, we found that recycled polyethylene caused a softening of a collation shrink blend we tested and a stiffening of a bag blend structure we tested. Anyway, we think that a co-extruded boosting structure could compensate these mechanical properties decrease. Everything depends on the final application, of course, of this film, on its thickness, and of course on the content of recycled polyethylene inside. In fact, we think that already this first test give already some hints about the RPE content, the maximum required percentage of recycled polyethylene. For example, on bag structure, we recommend to use 30% of recycled polyethylene and not more, because it caused a very strong decrease on dark drop impact resistance. We measured also some other properties like shrinkage behavior and sealing force, obtaining quite good results. And we measure also coefficient of friction, which was actually quite high, but can be adjusted by adding some sleeping additives, for example. As the final step, we produced a 55 micron film, and you can see the bundle in the slide we obtained with it, with 30% of RPE content, with quite good result. So collation shrink could be a proper application for this kind of material, but we think that also other secondary packaging not intended for direct food contact film could be evaluated. Okay, that's all from myself. Thank you, Alec.
Thank you, Valentina. Great. Now, if we go over to what's been happening at RKW with Florian.
Thank you very much, Alec. So as Valentina also already stated, today the recycled polyethylene from the household collected waste is not really known as a material of such quality that could fulfill the requirements of high demanding packaging applications. However, with the materials retrieved from the CEFLEX trials, this has actually changed quite a lot. As you can see here on the left graph, which shows the mechanical properties of a film sample made out of 100% RPE from the CEFLEX trials, the properties fall a little bit below the performance of the reference film, which was made out of virgin material. Nevertheless, if you look at the right graph, which shows actually the mechanical properties of a formulation which was especially designed by RKW for the usage of RPE contents, the mechanical performance can be elevated and almost actually balance the properties compared to the reference. This analysis show that with a clever formulation, RKW is able to produce films with a high content of RPE from the household collected waste stream without significant loss of mechanical performance. So even at rather high contents of RPE, as you can see here, we're using 42% in that RPE formulation. If we're then going on the next slide, as a conclusion, the conducted trials proved that the quality of the retrieved RPE grade by the CEFLEX trials is suitable for high quality packaging films, mainly for non-food application. And the RPE natural DSD, which we tested by RKW, provides a good compromise between the mechanical properties and the optical properties, with only a minor influence on the coloration of the film. Therefore, this grade is seen as very interesting for further developments, and we're really looking forward to the next industrial scale trials with CEFLEX. A first run was also done on an industrial production line, whereas the small samples were only done on a small lab line. But also here, it gave quite promising results. As you can see on the picture, we produced a 38 micron collation shrink film, which performed quite well on a 6 times 1.5 liter pack. That's also what you see on the picture. And this pack has also been shown during the K-show. That's from my side, an overview and conclusion on the materials. Thank you very much.
Thank you, Florian. That's great to see that example there. We're also going to speak with Monica Battistella of Taghleef. And Monica, can you talk us through a little bit of your analysis results, please?
Yes, good morning, Alec. Good morning, everybody. So we received different batches of RPP pellets, resins from EREMA. These pellets were mixed together and we planned an extrusion on one of our lines here in Italy at the beginning of August last year. So what we did basically was to mix the different batches we got, and we aimed to produce a wide voided film in 14 micron thickness with a density of 0.70. We started from a zero content to have a reference sample, and then we increased step by step the content of RPP resin, and we could reach at the first step 16.2% content, and then increased up to 32.4% content. Of course, this you can see in the slide, by increasing the content of RPP resin, there is an impact from the aesthetical point of view, though we consider it as being a minor impact. We have also counted the number of spots which could detected on reference samples, and on the samples showing 16.2% content of RPP and 32.4% content of RPP. And what we could find was a significant change by moving from 16.2 up to 32.4. So it was more or less 4 times more. But this was expected, so it was not really a surprise, of course. Then we carried out many different tests on the samples, keeping in mind that this product has been produced on a tenter frame technology, which means that the film has been stretched in both directions, machine direction and transversal direction. As you can see from the slide, what we see here is the measurement for tensile strength, elongation at break, and elastic modulus, where we have the reference samples as well as different samples showing different contents of RPP. And the result is very good, is excellent, because we could not notice any major difference between reference sample and the other ones. So because of the good performance on the line of the film and all the measurements that we carried out that confirmed that the film having RPP content is in line with reference films from many perspectives when we talk about mechanical properties, slip properties, puncture resistance, and so on. So we believe that this film is suitable for applications which do not go into direct contact with food, such as labels or pouches or overwrap, because it is basically equivalent to a standard UPP film grade. This would be all from my side. Thank you, Alec.
Thank you, Monica, Florian, and Valentina. I think we're really seeing that there is some additional value being generated there, and also in the applications and performance. So I think I would like to also now take it back to Dana. Can you try and associate a little bit for us and put this into context about what's going to happen now?
Sure, and actually I'm going to lead us to a conclusion, because we are supported by all the fact-based evidence. We are saying today as CEFLEX that in our sustainable end markets work stream, through the validation, and please show the next slide, through the validation of these processes at experimental scale, next slide please, and based on the converting trials with the resulting materials, as you have seen from all the speakers before, we had run the proof of concept, which demonstrates that recycling is possible for flexible packaging back to non-food flexible packaging through mechanical recycling via the quality recycling process. So we are here, Alec, to share with our external stakeholders in the value chain that we had reached an important key milestone. And in fact, the work we've done so far embodies our mission circular, designing, specifying, and delivering the value creation for flexible packaging. Next slide, please. So on our roadmap, armed with detailed technical applications and solutions to achieve a circular economy, we are advancing as planned. We are at midway towards the end goal, and 21 will be the year to prove the business case for investment and for the whole value chain to be able to feel comfortable walking the talk of the quality recycling processes. And this is really bringing our CEFLEX story on quality recycling processes to an end. And I think that we're getting ready to open for questions, Tim.
Great. Thank you very, very much, Dana.
So we're ready to take some questions, I understand, from our audience. We've had some really great questions coming in. Let's take one first of all from Tristan Davis, who I know is part of the Sustainable Packaging Coalition and based in Europe. Tristan has asked about certification and how it applies across Europe. She's asking specifically, are there different qualifiers for what constitutes recyclable in different countries? Anyone who would like to take that, perhaps Dana as a starter.
As a matter of fact, I would invite Michael Langan to answer this, especially because it's a European-wide type of question. Michael?
Yeah, I like to answer, sure. The certificate is issued with respect to a certain country, because as I explained previously, it does reflect actual collection and sorting infrastructure, which varies in the different countries of Europe. So the certificate issued for an individual packaging, it is stated clearly on the cover sheet of the full report for which of the European countries the certificate is valid. Would that answer the question raised, Tim?
Yeah, thank you very much, Michael.
Welcome.
Okay, so we have another question from Anthony Payton. He's asking, if packaging is commingled at collection, how is it that paper can be separated from film?
Oliver, I think that you're the one to pick the question.
I think so.
Yes, yeah, and that's actually a rather simple task. So we use near-infrared technology that kind of detects, we call it the fingerprint of a material, and let's say a PE film or a plastic in general looks totally different than a paper. So we are able to separate both paper as monofraction and plastic, separate plastic and monopolymer types.
Thank you, Oliver. We have another question from Michael Bonin. He was not sure what was meant within this presentation by the drop in the separation process. Asking for clarification. Is that the waste that can't go into washing and regranulation?
I'm going to take this question. So the whole principle of the quality recycling process is to increase the value of what is being recyclable and recycled, and not to decrease the recycling rate. So we're basically starting from a already established type of specification, like let's say the famous DSD 310, which will go as it is to a recycler. We are skimming the film fraction for more valuable application like higher performance film, and all the rest, we simply call it the drop, because what's happening is it should go as such without generating any residue into a new application. Therefore, within the quality recycling process, this drop, so all this rest, will also be submitted to hot washing and extrusion with extra filtration, such as it does get the benefit of advanced decontamination. Therefore, the value of the drop is normally at least the same with the infeed material, if not higher.
Thank you, Dana. We have another question from Carole Manceau. She's asking, are RPE films food grade? I suppose, can we expand on that and talk about how technology can advance and to what extent they may be extended in their food grade certification in the future?
Food grade is coming in a recurring manner as a question. And I think that the industry in general is agreeing that today, through mechanical recycling, food grade quality is not possible. And the hurdles to get the quality match the requirements set by regulation are quite high. So in the near future, in short or mid-term, we are not seeing mechanical recycling able to deliver for flexible packaging food grade. We are rather looking at chemical recycling as a complement to mechanical recycling to deliver food grade. However, we're not saying it's impossible. We're simply saying that with the technologies today and with the state of the art of collection today, there are legal hurdles which are hard to pass. One example is that EFSA is requiring for food grade to be able to prove that over 95%, at minimum 95% of the material collected is of food grade. So, impossible today.
Thank you, Dana. We have another question which was specifically for Barry Bellert. This has come from Ankit Agarwal, and he's asking, you mentioned that design must follow functional applications, thereby making it possible to optimize necessary performance parameters for the manufacturing, accompanied by customers' acceptance towards minor imperfections. As a practitioner, what are the key drivers to enable this change in the near future?
So, Alec, Tim, this last sentence you mentioned was?
Sorry, the last question. The question itself, as a practitioner, what are the key drivers to enable this change?
Okay. The key driver to which must lead to an acceptance of, let's say, a less shiny or glossy appearance of products, I think it's in education and spreading the news. Like I say, that these imperfections, as we see, is not a matter of not functioning. By example, maybe the same with the car industry. If we buy a new car, everybody wants it to be fully shiny and without any imperfection. That's what we like. That's what we pay for, we think. So if on the car bumper or in the coating is one tiny imperfection, maybe a tenth of a millimeter, our eye sees this and says, okay, this is not okay. So the product is not okay. So if we extrapolate this to packaging, and if we have the same behavior, then what happens, because from the past that film had to be perfect without any imperfection. So we have to explain it 100,000 times that this imperfection is not an issue of not functioning. It's just the imperfection is there, but it means it still can function 100%. So I think it's about education, just spread news, that people talk about it, maybe even demonstrate that the functioning is not the issue. I hope so.
Thank you. We've had another question, which I guess this could be the subject of an entire webinar in itself. So perhaps we can only touch on it in a general terms, but it's an interesting topic about the viability, economic viability of chemical versus mechanical recycling. I don't think we can answer this in full at the moment, but is this something that is a key area of analysis for CEFLEX, that you're looking at the viability in terms of what the market can support? Dana?
Yes, absolutely. And probably everybody heard me today at least a couple of times mentioning that everything has to be supported by a business case. And as a matter of fact, we have a full work stream which is focusing on building the tool which will enable us to create a business case for every recommendation which we come up with. Because also many times in this call, the topic of cost and price and the value perception came up, and we all know that if you want to change, and especially when it's not a cost reduction, you need to have a justification. And clearly, changing the state of the art today means investment. Michael told about the infrastructure cost and everything. Therefore, the industry needs the business case.
Great. I think that's...
May I add something about this issue?
Certainly, Michael.
I think it is not that much about the comparison between mechanically or chemically recycled plastics. It is more about the comparison between the recycled plastics and the virgin plastics. So right now we do see in the market a competition between virgin and recycled material, which is not on a level playing field. And why is that? It is because the recycled plastic carries all the cost of collection, of sorting, of washing. And beside that, it is less accepted in terms of the qualities. What we learned today in the webinar is from all the application engineers that they do see a very wide range of suitable applications for that. But when we see it from the market perspective, all the recycled blends, they carry the cost, as I mentioned before, of collection, sorting, and washing. And that is a perspective that needs to be changed. So the costs of these things need to be internalized and reflected even in the virgin prices.
Thank you, Michael. I see that our time is up now. We do have a few more questions that came in, and I apologize to the audience members who've not had their questions answered. If you'd like to maybe submit them to us by email to Packaging Europe, we can put those out to the CEFLEX team and stakeholders and see if we can get answers to those. It remains to thank Dana, Alec, and all of the CEFLEX stakeholders for your fantastic contributions today. Thank you very much for joining us. We're really looking forward to following the progress and supporting your progress as a group of stakeholders across the whole value chain. Yeah, it's really inspiring what you guys are doing. Well done. To the audience, thank you very much for tuning in today. We have another broadcast at 2 o'clock in the afternoon today, Central European time. Hope you can join us for that. Further broadcasts on Friday, Monday, and Tuesday as we have our kind of Ghost Interpack week following all of these topics that we would have been discussing in Messe Düsseldorf. Thank you very much for joining us and hope to see you soon. Goodbye.